Assalamu alaikum. My today's video is on the topic momentum. And this video is actually, it has some parts, like first part. In the first part of this video, I will discuss about the momentum's definition and some simple numericals. And the next part of this video will contain law of conservation of momentum, elastic and inelastic collisions, and Newton's third law. In first part of the video, we will discuss momentum, its definition, its relation to the second law of motion. So here are some specifications. You will be studying forces, movement, shape, and momentum. And we will study the basic formula of momentum, that is mass into velocity. And we will discuss some safety feature, and law of conservation of momentum will be discussed later on. In first part of this video, we will discuss a simple basic definition of momentum and impulse, and its relation to the second law of motion. So the rest of the parts, like conservation of momentum and its relationship with the Newton's third law, we will study later on in this other video. So momentum, it's a vector quantity. It means it has both magnitude and direction. Momentum, what is the definition? Mass into velocity. It is actually the characteristic of a moving object. Any object which is in motion, of course, it has a mass as well as it has the velocity. So, okay, the product of mass into velocity is momentum. We know the SI unit of mass, that is kg, and velocity meter per second. Okay, symbol for momentum is P, and mass you already know, M and V. Okay, so measured in kilograms, that is the unit of mass, velocity meter per second. So the new unit of momentum is kilogram into meter per second. So momentum has both magnitude and direction. It means it is a vector quantity. Okay, so any type of collision, the body moving, ball falling towards the earth, ball moving towards the wall. Okay, they all are the examples of momentum. Ball bounces off, it hits the ground and bounces off. It hits the wall and bounces off. They all have the momentum. The faster the body moves and the greater mass it has, the greater will be the momentum. Like truck moving at 20 meter per second has greater momentum compared to the car, which is also moving at 20 meter per second. Okay, because the velocity is same, but the mass of truck is greater. Now let's solve some simple questions. Calculate the momentum of a rugby player, mass 120 kg, moving at 3 meter per second. So this is the formula, and the values are substituted. And it is always good when you incorporate unit along with the calculation. Like mass is measured in kg, so it is written here 3 into 3 meter per second. So answer is 360 kg meter per second. There is another question. Calculate the mass of a car that when moving at 25 meter per second has a momentum of 20,000 kg meter per second. So here the mass has to be made subject. P is equal to M into V. So mass is equal to P divided by V. So 20,000 divided by 25. So mass comes 800 kg. Now here is small table to be completed. Some unknown quantities are given, like momentum is not given, mass and velocities are given. So we all know what comes in this. So we will multiply 50 into 3, we will get the value of momentum. In the same way, here mass is missing. In the next example, velocity is missing. And then here the mass is given in kg, grams. Okay, so mass has to be converted in kilogram. In the same way, in the last last example of this, mass speed is given in centimeter per second. So that must be converted into meter per second for the momentum to be in kg meter per second. Okay, let us have the answers. So 50 into 3 is 150. Here, momentum is given 160. So that will be divided by velocity. Answer will be 8. 160 divided by 20 is 8. Here, the velocity is to be found out. So V is equal to P divided by M. So 6 meter per second. Here, 4. Okay, so 0.5 into 8. When we convert mass, which is given in gram into kilogram, means we divide by 1000. Okay, so that will give you 0.5 kg. So 0.5 kg into 8 is 4 kilogram meter per second. And this is the last one. Okay, so here the velocity is in centimeter per second, means 0.5 meter per second. So 0.5 into 6 is 3. Now force and momentum. We know about the Newton's second law. What does Newton's second law say? Whenever any unbalanced force acts on the body, it accelerates the body in its direction, and magnitude of acceleration is proportional to applied force. So here, when the force acts, the velocity changes. Force actually, it is an agent which may accelerate the body, which may change the shape of the body. Okay, it may change the direction of motion. Okay, so here, suppose initial velocity of the trolley is u, and the velocity is, the final velocity after the force acts on the body is v. Velocity has changed. So it means momentum has changed. Okay, so force causes change in momentum. Okay, a force will cause the velocity of an object to change, and therefore also is its momentum changes. Okay, initial momentum, suppose mass is 2 kg and velocity is say 2 meter per second, and finally the velocity becomes say 10 meter per second. So momentum has changed. Final momentum is m into v, and initial momentum is m into u. Okay, so that happens due to the force which acts on the body. Okay, so the greater the force, the faster the momentum changes. Momentum, acceleration, and force. Now, a body of mass m changing its velocity from u to v in time t. Of course, for any event, the time is taken. Okay, when ball hits the ground and bounces off, the time is taken for that short period of time. Ball will be in contact with the ground. So, time will be elapsed in any event. Okay, so acceleration is equal to change in velocity divided by time. This is the definition of acceleration. Acceleration is rate of change of velocity. That means change in velocity v minus u over t. Okay, now we are going to relate this Newton's second law, F is equal to ma to momentum. So multiply both sides of this equation, a is equals to v minus u upon t. We will multiply it by m. So what comes? M into a, and v into u is also multiplied by m divided by t. So m into a is what? Now it's mv minus mu, final momentum minus initial momentum divided by time, and that is ma. And ma is equal to the force. Okay, that is the Newton's second law. It is an unbalanced force. When forces are balanced, means body will not accelerate. Okay, it will continue moving with the uniform velocity, or if a body is at rest, in the absence of any unbalanced force, body will continue its state of rest. Or if it is moving with the uniform velocity, it will continue moving with that uniform velocity. But the force is unbalanced, means one force is greater than the other. So there is an unbalanced force acting on the body. So that will cause body to accelerate. So ma, so we will replace mv minus mu is equal to the change in momentum. So let us see now. F is equal to mv minus mu upon t. Change in momentum, mv minus mu is change in momentum and divided by time. Okay, so that is equal to F. Let's have a look at it again. mv final momentum, mu initial momentum divided by time. Okay, so that is equal to 4. So Newton's second law can be stated in this way also, that whenever any unbalanced force acts on the body, it changes the momentum, and change in momentum takes place in the direction of force. Okay, so force is equal to change in momentum divided by time taken for the change. So force is measured in Newton. Change in momentum is measured in, change in momentum is momentum. Okay, if we subtract one momentum from other momentum, like final minus initial, the answer will be momentum. So unit will be the same, kg meter per second. Okay, so let us see. So time is measured in second. So it's kg meter per second over second. kg meter per second upon second. So it means the change in momentum can be expressed as Newton into second. Change in momentum in the numerator, time is in second. So force unit is Newton. So Newton into second is also the unit of change in momentum. Change in momentum is not only kg meter per second, it's also Newton into second. Okay, and change in momentum is defined as impulse. Okay, so impulse is the change in momentum of an object. If the initial momentum of an object is suppose P1, mu, okay, and final momentum due to application of force is P2, that is mv. So it means the object has some impulse. Okay, so impulse symbol in most of the books, in most of the discussion, impulse is given a symbol J, P2 minus P1. Okay, let's go to the previous slide once again. So change in momentum is also equal to force into time. Change in momentum is impulse. So impulse is equal to force into time. So one is change in momentum. Another definition, impulse delivered by a steady force acting on for time t is J is impulse, F into delta t, the time for which the force acts on the body. Okay, the greater the force, the longer it acts, the more will be the change in momentum. Okay, more will be the impulse and more change it will bring in the momentum. Okay, so here the golf player, if she hits the ball, it means she applies the force on the ball. Okay, so it means the momentum of the ball changes. Okay, so SI unit of impulse is Newton into second. Change in momentum. Okay, so kg meter per second is also the base unit. Calculate the force required to change the momentum of a car by 24,000 kg meter per second over a 6-second period. So change in momentum is given. We don't know what was the initial momentum and what will be the final, but the difference of final minus initial momentum is 24,000. Okay, the momentum has changed due to application of force, and force is acting on that body for 6 seconds. So you have to calculate the force acting on that body. So force is equal to change in momentum divided by time taken. Change in momentum is given 24,000 and time is 6. So 4,000 Newton force acts on the body and brings the change of 24,000 Newton in the momentum of the body. Another question. Calculate the time taken for a force of 6,000 Newton to cause a momentum of truck to change by 42,000 kg meter per second. The momentum of the truck is changing. Okay, so you have to calculate the time. Force is given. Okay, and change in momentum is given. Okay, force is equal to change in momentum divided by time. So time is to be found out. Force is given. That is 6,000 Newton. Time is to be found out. Momentum change is 42,000 kg meter per second. So let us see what comes. Time taken is made subject here. Okay, so change in momentum change divided by force. Okay, so momentum change is 42,000 and force acting on the truck is 6,000. So that will be 7 seconds. It will take 7 seconds. The force has to act on the body for 7 seconds so that the momentum changes. We don't know what is the initial and what will be the final momentum, the change in momentum. Body might be having 0 momentum in the beginning. What does that mean? Body might be at rest. Okay, and body starts moving with certain velocity. Okay. Now there is a table to complete. Force is missing. Time, the momentum change is given, time is given. Okay, let us see. And the same way in the second part, momentum change is missing. Third part, time is missing. Then again, force is missing. Then momentum change is missing. But here the time given is in minute. Let us see the answers. So first part, what you may guess, 8,000 Newton, 8,000 kg meter per second divided by 40, because force is equal to change in momentum divided by time. So answer will be 40. For 8,000 divided by 40 will be what? 200. Okay. Now here, the next part, the momentum change is missing. So change in momentum is equal to force into time. Change in momentum is impulse, that is force into time. Okay. If you have, suppose you have to find out the change in momentum, you have the initial and final momentum, you can find out the simply difference. Okay. If the time and force are given, then you can find out the impulse by multiplying force with time. F into T is impulse or change in momentum. Okay, so 25 Newton and 20. So force into time, 25 multiplied by 2 is 100. When it means answer will be 1000. Answer will be 25 into 2 is 50, sorry. And that is one more zero comes here, 500 kilometer per second. Now here, the next question is, it is answer has come. Let us solve this. Force 500, change in momentum this. So what will be time? Time is equal to change in momentum divided by force. So two zero zeros will be cancelled. 5 6 are 30. Okay, here force again is missing. So that will be 800 because change in momentum divided by time. Now 4 Newton, what will be the change in momentum? 2 time is 2 minutes. 2 minutes means how many seconds? 2 into 60, that is 120 seconds. So 120 into 4. Okay, so that is 480 kg meter per second. Okay, so the momentum conservation we will discuss in the other part of the video. Okay, first we will solve some more questions related to impulse, change in momentum, and force. Here I have some more questions. These are MCQs. An object of mass 4 kilogram is moving with a velocity of 3 meter per second in a straight line. What is the momentum of the object? So 4 kilogram is the velocity and 3 is the 4 kilogram is the mass and velocity is 3 meter per second. So 4 3s are 12. Okay, so C is the answer of this question. Let us go to the next question. To a ball of mass 0.5 kg falls and hits the floor at 10 meter per second. It means when it hits the ground, its speed is 10 meter per second. Okay, and during the impact, ground applies the force on the ball and its rebound velocity is 8 meter per second. The collision between the ball and the floor lasts for 0.5 seconds. So what is the average force acting on the ball during the collision? So here we have to take care of sign convention. Why? Because momentum is a vector quantity. So one side direction is taken positive, then the opposite direction will be taken negative. Okay, so let me solve this question here. So here the velocity is u, initial velocity, and this is v. We will, if we take down positive, means up will be negative. What will be the initial momentum? For the initial momentum, we will have to see the mass once again. What is the mass? 0.5 kg. Okay, so mass is 0.5 kg. So what is initial momentum? P1, and that will be equal to m into v. Suppose we have taken down positive 0.5 into 10. So answer will be 5 kg meter per second. Okay, now final momentum. P2 is equal to m into v. What is mass? 0.5 velocity. Now it will be having negative sign with it. Okay, because up is negative. So 0.5 into 8 is 4, and that will have minus sign. Kg meter per second. Okay. The collision lasts for 0.5 seconds. The time during the collision is time for the collision between the ball and the ground is 0.5 seconds. So what is the relationship between force, change in momentum, and time? F is equal to mv minus mu over t. mv minus mu over t. mv, final momentum, minus 4. Minus is the sign from the formula. And initial momentum is 5 divided by 0.5. That is minus 9 divided by 0.5. So that is minus 18 Newton. That is kg meter per second and second. Okay, the second goes up. That will become kg meter per second square. Okay. So that is 18 kg meter per second. And this is in the numerator. That will also be with this. So 18 kg meter per second square means 18 Newton is the force which is acting. And the minus sign indicates what? That is upwards. Let us see what answers are there. Okay, so 2 newtons upwards, 2 Newton downwards. No, 18 Newton downwards is also wrong. 18 Newton upwards. You could have done the thing in the other way around also. What? You could have taken down positive and up negative. If you take down negative and up positive, what will happen as a result? Suppose you have taken down negative and up positive. Let us see what comes. Initial momentum P1 is equal to mu. Okay, so 0.5 into minus 10, that is minus 5 kg meter per second. And what is final momentum after the collision? That is mv, and this is 0.5 into now positive. Up is now positive, 4 kg meter per second. So F is equal to mv final minus mu over t. mv4 minus is of the formula and minus 5. Okay, divided by time for the collision is 0.5. So 4 minus plus, that is 9 divided by 5.5. So that again is 18 Newton. Now it is coming positive and that is upward again. Okay, because up is now positive. So our change in momentum is 18 Newton upwards. Let's go to the next question. An object of mass 0.5 kg accelerates from a velocity of 2 meter per second to a velocity of 10 meter per second in the same direction. Direction has not changed. Okay. Body is accelerating. Velocity changes. What is the initial momentum? Mass into initial velocity, and final momentum, mass into final velocity. So what will be the impulse? We have studied impulses change in momentum. Okay, so let us solve this question. Now 50 kg and velocity changes from 2 to 10. Change in momentum. mv minus mu. Okay, and that is equal to F is equal to this. It means change in momentum mv minus mu equals to force into time. But neither we have force nor we have time. Okay, so it means change in momentum can be calculated simply by subtracting the two momenta. Plural of momentum is momenta. Okay, so final momentum mass is 50 kg into velocity, final velocity is 10, 50, and that is 2. Okay, so this is 500 minus 50 into 2 is 100. So answer is 400 Newton into second. This is Newton and second. So impulse unit is Newton into second. So answer will be B. Okay, let us go to the next question. A resultant force of 4 Newton acts on an object of mass 0.5 kg for 3 seconds. What is the change in velocity caused by this force? Okay, so here the force of 4 Newton is acting on the object of mass 0.5 kg. The time for the force, which is for time for which the force is acting is 3 seconds. So mass is also given. So we can have the formula what? F is equal to mv minus mu over t. Okay, so F into t is equal to mv minus mu. So 4 Newton for 3 seconds. Mass is given. So what is the change in velocity? What will be change in velocity? It means we will make change in velocity the subject of the formula. Okay. The 4 Newton, 0.5 kg and 3 seconds. So here 4 Newton, 3 seconds. So 12 into 0.5. V minus U. So what will be V minus U? Equal to change in velocity, final minus initial, 12 divided by 0.5 equals to 24 meter per second. Okay, so remember one thing. This impulse, that is the change in momentum. Velocity changes by 24 meter per second, but what is the change in momentum? 12 kg meter per second. Force into time is change in momentum. Same impulse will always bring same change in momentum, whatever is the mass of the body. Let us have some more example of this. Like I will just elaborate it a little more. Suppose this is the impulse, 12 kg, and mass is 0.5 kg. Okay, suppose initial velocity is 0. So what will be the final velocity? Impulse is equal to mv minus mu. 12 is equal to 0.5 into v minus 0, because 0.5 into 0 is 0. So what will be the final velocity? 24 meter per second. Okay, suppose the mass is now 2 kg. Now the change in momentum will be the same. Okay, and the velocity will be different. because the body is now heavier. Let us calculate the change in momentum for this body, which is having and same impulse. It means same force of 4 Newton is acting for 3 seconds. Same force is acting for 3 seconds. So impulse is 12 kg meter per second. Now mass is 2 kg. So 12 is equal to mv minus mu. Okay. So m is 0.5, sorry, now not 0.5. Now in this case, m is 2. 2 into v minus 2 into 0. 2 into 0 is 0. So now what will be the final velocity? 6 meters. Okay, so change in momentum again is same. You can check change in momentum. Initial is 0. So final is mass into velocity. Mass into velocity is 2 times 6 is 12. So same force which is acting for the same time will bring same change in momentum. Suppose in the two examples, the body was initially at rest. Suppose body was already moving with certain velocity. For example, body U is moving with initially 2 meter per second. Okay. So what will be the final velocity when a force of 4 Newton acts for 3 seconds? Now body initially is moving at 2 meter per second. Mass is 2 kg. Initial velocity is 2 meter per second. What will be the final velocity? Let us check. Impulse is equal to change in P, change in momentum, delta P. Okay, so impulse, 4 Newton force acts for 3 seconds, that is 12. mv minus mu. 12 is equal to 2 into v minus 2 into 2. 12 is equal to 2v minus 4. This 4 goes to the other side. 2v is equal to 12 plus 4. So that is 16. So v is equal to 8 meter per second. Okay, so when the body was already in motion, now let us check whether the impulse is again coming 12 or not. mv minus mv minus mu. If we check 2 into 8, final velocity is 8 minus 2 into, what was the initial velocity? 2. So 8 to the 16 and 16 minus 4 is 12. Okay, so same impulse, the force which is acting for the same period of time, whatever is the mass of the body, that will bring same change in momentum. Okay, let us now have a look at the other question. Here, the figure shows a tennis ball. This is from IGCSE, variant 43, October, November 2022. Figure 2.1 shows a tennis ball. That means it must be question number 2 of that year. Ball approaching a tennis racket. Okay, so of course, when it is in contact, the force, the both bodies will apply force on each other. Okay, the ball will apply force on the racket. Racket will apply force on the ball. The tennis ball hits the racket at a speed of 52 meter per second. The average force on the ball during the time it is in contact with the racket is 350 Newton into second. The speed of the ball after it leaves the racket is 26 meter per second in the opposite direction. So the first velocity is towards right, that is 52 meter per second, and second velocity is towards left, that is 26 meter per second. Okay, so and leaves the ball in the opposite direction to the initial speed of the ball. The mass is 58 gram. So here you have to remember mass is given in gram. So that must be converted into kilogram. Okay. Mass, initial speed 52 towards right. Okay, and the force is 350 Newton. Let us write the data there, and we will calculate. We have to calculate the change in momentum. So F 350 Newton, initial velocity, that is towards the racket, that is 52 meter per second. So we take, suppose right positive. If right is positive, then left will be negative. Okay, so plus 52 meter per second. Okay, and V, it bounces off with the velocity of 26 meter per second. So that will be minus 26 meter per second. If you don't take care of signs, your answer will be wrong. Okay, so let's see, the mass is 58 grams. So you have to calculate the change in momentum. Okay, so mass of the body is 58 gram, means 58 divided by 1000. That will give you 0.058. Okay, so change in momentum is equal to mv minus mu. 0.058 minus 26. Okay, minus 0.058 plus 52. So answer will be negative here. 0.058 into 26. Answer is 1.508. And that is negative. Then minus sign. Then this is 52 is actually double of this. So it will be twice of this, you can say. 0.058 into 52 minus 3.016. So if you subtract, what will be the answer? It will be negative. Minus minus will be plus. So we will add. Okay, 1.508, 4.524, 4.524 with negative sign. And according to data, we have two significant figures in the all the data. Okay, so our answer should also have two significant figures. So what will be the answer? 4.5 towards what answer is coming? Negative. Negative is taken. Which direction is taken negative? Right side. So 4.5 Newton into seconds or kg meter per second towards left. Our left is negative. Okay, not right, sorry. Okay, right is taken positive, so left is negative. So that is the change in momentum towards left. Okay, either you put minus sign or it's better you mention the direction. Okay. Now let us see the next part of the question. State an equation which defines impulse in terms of force and time. So that is force into time. Impulse will be force into time. Calculate the time the racket takes, the time the racket is in contact with the ball. Okay, so here force is 350 Newton and change in momentum is 4.5. F is equal to change in momentum divided by, you can write delta P over T. Okay, F is 350 is equal to 4.5 divided by T. So what will be the time for which the ball is in contact? So 350 divided by, sorry, I'm doing wrong here. Cross multiplication is to be done. T goes there, 4.5 divided by 350. So I will just simply divide this. Our answer will be slightly different because I have taken, I've rounded off. So it is in contact for about 0.01 second. 0.012 seconds. Okay, so if you convert it into millisecond, what will be the answer? You multiplied by 1000, that is 12 millisecond is the time of contact. Now, change in kinetic energy. Calculate the difference between the values of the kinetic energy of the ball before and after the impact with the rocket. So, before the impact, what was the velocity? 52 meter per second. And what is the velocity after the impact? That is 26. So, what is the difference in kinetic energy? Initial KE, half mv square, that is mu square, half into 0.058 into what was the initial velocity? 52. Since energy is a scalar quantity, so we don't have to take the sign in this. Whatever is the magnitude, we will take the magnitude. So initial KE is 52 square into 0.058, this divided by 2. That is 78.4 joule. Final, you may write EK also for kinetic energy. Half, mass is same, 0.058 into V is 26. Let us see what comes. Uh, 26 square into 0.058 divided by 2. So 19.6. It means final KE is less. So what happens to the change in kinetic energy? That appears in the form of heat that may be used up in the extension of the net of the racket. Okay, some like some little deformation may take place. Okay, so in deforming the bodies and heat. Okay, so difference now 78.4 minus 19.6. 78.4 minus 19.6 is equal to 58.8 joule is the change in momentum. Okay, so 58.8. So change in KE is 58.8 joule. So rest of the questions are related to law of conservation of momentum, which we will have inshallah in the next class. So now Allah Hafiz, and inshallah we will see each other. We will have another class related to momentum part 2. So this is momentum part 1 along with some questions. The next video will be uploaded soon on momentum part 2, in which we will discuss the question on law of conservation of momentum. Okay. Allah Hafiz.